What is Q-value in reinforcement learning? Imagine you're playing a game where each move you make can lead to different outcomes. Some moves give you points right away, while others set you up for bigger rewards later. How does your game character decide which move to make? That's where the idea of Q-values comes into play. In reinforcement learning, the Q-value is a number that tells an agent how good a particular action is in a specific situation. Think of it as a score that predicts the total rewards you can expect if you choose that action and then keep playing optimally. It's like having a forecast for how beneficial a move will be over the long run. The Q-value is written as Q of S and A, where S stands for the current state and A is the action you're considering. It estimates the total reward you'll get starting from that state and action, including both immediate gains and future rewards. The idea is to balance short-term benefits with long-term gains, which is done using a discount factor. This factor helps the agent decide whether to go for quick wins or plan for bigger rewards down the road. Q-values are at the heart of a popular reinforcement learning method called Qlearning. This method updates the Q-values based on what the agent actually experiences. It uses a formula called the Bellman equation, which combines the reward received now with the highest Q-value of the next state. This way, the agent learns which actions lead to better outcomes over time. In simple terms, if the Q-value for an action is high, it means that action is likely to lead to good results. If it's low, the agent might want to avoid that move. To keep track of these values, small problems use a table called a Q table, where each row is a state and each column is an action. For bigger problems, neural networks can approximate Q-values, like in deep Q networks. Q-values help agents decide when to explore new actions and when to stick with what they know works. For example, they might try a new move to see if it's better, or they might stick to a known good move. This balance is often managed with strategies like epsilon greedy policies, which sometimes pick random actions to discover new possibilities. Understanding Q-values shows how reinforcement learning agents learn from experience to make smarter choices over time. These ideas are used in many areas, from game playing to robotics and autonomous systems. They also relate to how AI like ChatGPT or image generators learn patterns to improve their responses or outputs. In essence, the Q-value is a way for an agent to measure the potential benefit of an action in a given situation. It helps the agent learn which actions to take to get the most rewards in the long run, making decisions smarter and more effective as it gains experience.